Started. Hi everyone, my name is Mark Adams and I am here to give a talk on building Python web apps with Docker. Hopefully you guys are in the right spot. If not, feel free to leave. I can understand if you didn't want to hear about it. My name, like I said, is Mark Adams. I work for Atlassian. I'm a developer on the Bitbucket team in the Austin office, and I've been there since January. Before that, I worked at a healthcare software as a service company. Both places doing Python, both places doing Docker-y stuff, and it's pretty cool. I'm into anything really that helps developers ship things more easily and more quickly. So any tools surrounding that are my kind of thing, which makes Docker perfect for me. So much to the degree that I think some of my coworkers at Atlassian will attest. I'm pretty sure a drinking game may have developed around how many times I say Docker during our weekly team demos meeting. So this is a good outlet, I think, for me to get some of that excitement out. All right, cool. Well, let's get started. What we're going to hopefully cover today is, first off, this is sort of a beginner-focused session on Docker to give you guys an idea if you've heard of it, don't really quite know what it is or what it's for, but you know everyone likes it and therefore you should too. Then this is the right talk for you. We're going to cover what is Docker, what can it be used for, what's the point of it, why would I be interested in it. We're going to look at a brief sample application I've created. You guys are going to love it. It's a perfect example of a modern web app, has all the good things that a modern web app should have. And then we're going to cover the four of the biggest things about Docker that you should know about: the Docker engine, the Docker hub, Docker Compose, and Docker machine. Like I said, there's a lot of words with a lot of things with Docker in front of them there, so this presentation isn't going to get any lighter on that. All right, cool. So the first question, what exactly is Docker? You've heard a lot about it. Well, Docker is a system for containerizing applications. Okay, that sounds great. What's it mean? Well, I'll get into that. Let's think about how we deploy applications today. How many of you guys are web developers out there or ship code? Okay, cool, that's good. Good number of web developers. You guys will probably definitely understand the pain here. How many of you guys do research, academia, anything like that? Okay, cool, got a couple of those. Well, in all these scenarios, you have a lot of things in common. Like, you have code or you have an experiment and you want to share that code with somebody else, whether it be deploying it to a server or shipping it even behind the firewall, or giving it to one of your colleagues in academia to try to reproduce your experiment. But there's always issues, no matter what you do. When we have developers on board at Atlassian, they always wind up having issues with making sure dependencies are installed and that they have the right version of libraries and things like that. And it just messes everything up so much that we have entire groups of people that are, DevOps, ops type people who deal with keeping our applications online half the time, because who knows what's going to happen the next time you push that deploy button. The way we deploy applications today tends to focus a lot around virtual machines, because we figured out how to do that really well. In the traditional architecture of how you would deploy apps to the cloud, you usually have a server out there somewhere, regardless of wherever you're deploying on the cloud. Somewhere there is a physical computer out there that your code is running on. Now, on that physical computer, just like your computer, there's an operating system, and usually there's a hypervisor that sits on top of that and will run virtual machines. That's usually what you see if you're looking at a lot of cloud services like AWS, Google Compute Cloud, things like that. And that hypervisor, on top of that, you have your virtual machines. And this is where things start to get interesting. The hypervisor emulates the hardware, right? It basically takes the instructions that virtual guest OS passes down and translates them into instructions for the machine using the machine's resources. Then on top of that, you have libraries, system-level libraries or application-level libraries. Maybe you're doing something with encryption and you have to have OpenSSL installed as part of that. And of course, as many of you know, having the right library to match your Python extensions can often be a make or break deal. So having the right C libraries and the right Python extensions all put together makes a really big difference in whether your app is actually going to work right most of the time. And then, of course, once you made it through all those layers, you wind up getting to the point where your actual code is sitting there and that's what's executing on the server. Some good things about that. We've gotten good at making it robust. We know how to take a plain Jane virtual machine on AWS and using tools like Fabric or Puppet or Chef, we know how to get that machine to look the way we want it to and have everything we want it to most of the time. But there's still issues where developers may change the library in a new version of the software. We may change the library that we're pushing up and not communicate that properly to the operations team. And as a result, when that code gets rolled out on the server, boom, first server it rolls out on dies in a fiery blaze of glory, and everyone's in incident response mode wondering what exactly happened. A lot of times virtual machines, if we want to scale up quickly and add more capacity, you probably should know about that ahead of time, because virtual machines can sometimes take 10, 15, 20 minutes to boot up, and then after that get provisioned with all the libraries and your code deployed to it. So it's not really a fast process, and there's a lot of extra stuff. I mean, you guys can see in this diagram, you have the host OS and the hypervisor. There's a little bit of redundancy there when you see that guest OS and everything else in that stack, and it just seems like surely there's got to be a way to make this a little simpler and a little faster and a little leaner. Well, that's where Docker comes in. Or there's this notion of containers. Docker's the leading framework for it right now. But what containers do is they take some of that stuff out of the picture. Mainly, the hypervisor and the guest OSs kind of go away. What actually happens when you're dealing with containers is your application and the libraries it depends on are packaged together in a common shared format. And that can be built by you, the developer, on your computer or in a CI build, and then deployed out to whatever cloud you're running on. And what actually happens is instead of it talking, like we had back here, instead of your application dealing with a guest operating system that's virtual and then talking to a hypervisor and all that translation and you're losing performance left and right happening there, the Docker container actually allows your application to interact directly with the kernel of the host OS, which means the performance is almost identical to what you would see with an application running on bare metal. And the way it accomplishes that is there's been a series of APIs in the Linux kernel for the longest time that help with doing some things called namespaces that help these processes get isolated. Those of you who are familiar with with isolating root file systems, it's a very similar concept in that these applications are started and their processes are restricted in such a way that they can only access the resources that explicitly they've been given access to use. And that's what Docker actually does. Docker manages that entire process for you. It takes all these different kernel APIs, libvirt, all these other things that are used in order to set up these containers, and it ties it together in a nifty little package for you with a bow on the top and says, here you go, ship your stuff, which is great. Important things to note about this architecture is it's lean, portable, lightweight, efficient, isolated, all the great buzzwords. But you can see here, instead of having to deal with provisioning an entirely new host and these guest VMs and all this stuff whenever you ship your app, all you actually have to do if you want to spin up more processes is just spin up more containers, either on another Docker host or on the same Docker host. The benefit here is a cloud provider can have a lot of those Docker hosts pre-provisioned, and there's no other configuration really needed on them. As long as they support Docker, they can run your app. And you don't have to worry about making sure the right libraries are installed or anything else like that. That's all wrapped up in the container or the image that you ship up. And I'll go into that terminology here in a moment. Okay, so we covered this a little bit already, but why are containers useful? Well, I'd like to believe containers are useful for doing all the things, okay? Whatever you want to do, containers can help you with that. And some common use cases, I work on the Bitbucket project at Atlassian. If you guys don't know what that is, it is a platform for code hosting and code review. It's targeted at professional teams to help people kind of manage their workflow and have their code together and be able to collaborate. It's really neat. One of the things that we did recently was we totally reworked webhook functionality within Bitbucket. How many of you guys know what a webhook is or are familiar with that concept? Okay, cool. Well, if you guys know what hooks are, it's a very similar concept, but it involves the web, and that's all I'll say. No, I'm just kidding. What webhooks do is whenever an action happens, let's say you push up your code to Bitbucket, you do a git push, ship your code up, and maybe you have some sort of code analysis tool that needs to run on your branch to make sure that your code passes all the checks that your team has set up. What happens is when you push to Bitbucket gets your code, and then we send off an HTTP post message to whatever URL you've told us to with information about that commit you just pushed up, so that whatever your code analysis tool is can get basically a push notification and know that your code is ready to be checked out and analyzed. It's really cool stuff. We built it kind of differently than we built a lot of other things. In particular, Bitbucket itself is a very, very large Django app entirely in Python. If any of you guys were at Euro PyCon a couple years back, one of our developers actually gave a talk on the Bitbucket internals that was really, really good. In this situation, what we chose to do was we chose to take the backend components for webhooks out of the main core of Bitbucket and turn them into a microservice architecture running on top of Docker. So some cool things about that: we were freed up in our technology choices. We didn't necessarily have to use the same stack that we were using in most of Bitbucket. We didn't have to use the same database. We didn't have to do a lot of things that would have been a problem otherwise. So as part of that project, we actually kind of did a full stack look at Docker. Local development is the first place where Docker is super useful to you. Do any of you guys use Vagrant images whenever you develop? Maybe your teams have dev VMs. Cool. Nice thing about Docker is once you have boot to Docker or Docker machine set up where you can run those, or if you're running Linux, just have Docker installed. Once you have those things on your workstation, spinning up a Docker container of your dev environment is a very, very quick process. As anybody who's provisioned a Vagrant VM knows, usually it's a great thing to do right before lunch. So it definitely speeds up that process, and it helps eliminate a lot of the issues that developers face with "it works on my machine." How many of you guys have ever said that? Well, it works on my machine. And we actually had an incident like that a long time ago. I was working with some code that had to do with crypto, and we discovered that there was a performance difference between reading from opening the OSU random or dev random file and reading random data from it, and using Python's os.urandom call. There was actually a performance difference between those two things, and that performance difference was inverted between Mac OS and Linux. So when we would run the code locally on our Mac workstations, one way would be a lot faster, but if we threw it up on our Linux servers, we ran into a totally different performance implication. Docker can kind of help you remove some of that confusion by giving you a common platform that you're running on in development and in production, which is pretty cool. Another place it's really applicable, if you guys do CI builds with something like Jenkins or Bamboo or Travis CI, your CI builds can actually take advantage of Docker as well. What's neat about that is for instance, on this webhook broker project, our application is built using Docker into an image that's then run through our test suite. And then that image is promoted to our staging and production environments. So you actually are deploying the exact same image. Every single bit of the image that we're deploying to production is the same as the one that passed all the tests. So you don't have to deal with any of this confusion around, your libraries or other things being incompatible, and for some reason another works on my machine case pops up where it works on your CI server, but then catches on fire when you ship it to production. And then, of course, like I alluded to, deploying to production and scaling is another place where Docker really shines. You wind up taking something that used to take a long time to do, provisioning a new VM to scale up more processes, can now be done just by creating a new container, which is a very fast and lightweight operation. So I know what you guys are thinking now. You're probably starting to think, I just want it. Just give it to me. I don't care any of the other information about it. I just want to use it. Okay, well, I'm going to tell you how to get it. The first step, if you have Windows and Mac, life is super easy for you. There's the Docker toolbox is the starting point for Docker. It's a neat thing that basically takes almost all the things I talked about at the beginning of the presentation, Docker client, Docker engine, Docker compose, machine, a nice GUI, and wraps them all together into one installable package for Windows and Mac, which is pretty easy. For Linux, it's also pretty easy. You just paste this wget command, it downloads a shell script that figures out what platform you're on and installs the Docker client and engine on your system. All right, let's talk about the architecture of Docker a little bit so we kind of understand what's going on through the rest of the presentation. When a lot of the stuff you do, almost all of your interaction with Docker is going to have to do with the Docker client application. It's a small CLI app. you type Docker, and it communicates with the Docker host, which is running, or the Docker daemon process, which is running on a Docker host server. That Docker host server can be your computer, or it can be a remote server in the cloud, really anything. So everything the client does is basically just sending commands and information to that Docker host. The Docker host is actually responsible for taking your source code and actually building these images, which then get turned into containers. And I want to take a moment to talk about that. The way Docker works is you go through a build process. There's a file that acts kind of like a recipe that we'll go into later called a Docker file. And when you build that Docker file, the Docker client bundles up all your Docker file and all the information, all your source code and everything, and ships it off to the Docker daemon on the Docker host. And it goes through and builds an image of your app, including everything that is up from the kernel. So if you remember that diagram earlier, that means all the system libraries. If you're using, let's say, Debian and you need to apt-get some packages that need to be on the server, all that stuff is included in the image. So the build process does your apt-get stuff, it does your pip stuff to install your Python dependencies, anything else you have that involves building, all happens in there, and you wind up producing this image. And then whenever you want to start an instance of the application, you use Docker run, and Docker takes that image and turns it into an actual running container on the server. And that will probably make a lot more sense as we go on through the presentation, but I just wanted to kind of give you a high-level overview. The important thing to understand is Docker build makes images, Docker run takes an image and creates a container, which is a running instance of your app. Lastly, the Docker registry is a very key component too that we'll go into. The public one is called the Docker Hub. There's a lot of images out there that are really useful and pre-configured to include a lot of the libraries and stacks that developers use most often. One of the things that makes Docker really cool is as you go through the build process, each step in the build process generates an image of a layered file system. So what that means is when you go to rebuild your Docker container, it doesn't have to rebuild things that haven't changed, which can be quite a time saver, especially if, let's say, your app requires the Ubuntu stack, for instance. Then your Docker host doesn't have to go out and download the Ubuntu stack every single time that you want to build a container. It can use all those same images for every container, every different app on your system, which is pretty neat. All right, time to talk about my demo app. For that, we'll go to Bitbucket, and hopefully that went a lot better than I thought it was. I was expecting my browser to like fall apart. We'll go to Bitbucket here and we'll look at this app. I've made a demo application here in Django that is a guest book actually, and I will show that to you guys here in just a second. I want to do a quick code walkthrough, give you an idea of kind of what's going on here. You've got a manage Py just like any other Django app. Got a requirements.txt. All we need is the latest and greatest Django. And let's go back here. There we go. We have one app in here, the guestbook app. You have all the usual suspects here. You have two models that we're interested in. We have a guest entry, which is somebody signing the guestbook and the timestamp for when they signed it. We have a hit, which is just got a primary key on it, nothing too interesting there. It's mostly just being used for counting the number of people who have visited this little web app. And then we have some tests in here to make sure that the app works right. I spent a long time on making sure this app was super robust for you guys. Basically, we just verify that the hit counter goes up by 1, verify that your name gets recorded properly on the guest book, stuff like that. And then there's our views where we actually do the real work of processing the user's HTTP request. So, the only other thing I want to show you guys is the settings file, because I did some neat things there that are just a little bit different than just a normal flat Django app, in particular with regards to the database configuration. I wanted this app to be able to work on SQLite and on Postgres. So what I've done here is I made it where if there's a database host environment variable, then it will assume we're wanting to run Postgres and will populate the database configuration with that information. Okay, cool. Good so far? App looks pretty straightforward. All the Django masters out there are suitably impressed with my awesome Django skills. All right, well, cool. Well, let's see what this thing is going to look like as a application in Docker. Okay, I have Dockerfied my app. That's how easy it is. You just go in, hit the menu, and hit Dockerfied, and you're done. That's not how it works. I I just prepared beforehand. So you'll see all I had to do really to get this example app ready is I added a couple files. I added this Docker ignore because I wanted to save myself some trouble and put in a credentials file that has all my AWS credentials, because I know you guys are developers, which means you can't be trusted at all. And the second my Amazon keys go up there, there'll be a million VMs provisioned on my account. So that's not gonna happen. The Docker file here is the recipe for our container. We'll go over that step by step in just a minute. Docker Compose, this is another Docker file we're going to be talking about as we go through this process. Before we continue, let's go ahead and I will activate my demo app here. We will run manage py-migrate to run the migrations and get the database ready. And then we'll run manage py run server. Oh, that port's already in use. That's awesome. Did I already start it? That would be awesome. Nope, that's my slideshow. That's awesome. All right. Let's see if I remember my... Yay, that looks good. Okay, and here's the app. I'll zoom it in so you guys can see it in all its glory. It is a guest book. It has a hit counter. You can see if I refresh my hit counter, it increments. And if I fill this out and I pick a name here, like mine, hit submit, it adds me to the guest book. How cool is that? I think this app is probably one of the best web apps. Oh, and of course, how can you forget the classic IE button? You guys would be amazed, you actually can't find these on the internet. I had to go to the Wayback Machine and find the GeoCities homepage to steal that. So that was probably the most time-consuming part of this entire endeavor. All right, let's hop back in here. Now that you guys have seen the demo app, you know what it does, you know how it works, we will begin looking at the different components here. Okay, first off, we have the Docker engine. When people talk about Docker most of the time, this is what they're talking about. They're talking about the Docker engine. The main point of it is, it builds the images and it runs the containers. So 90% of the stuff you care about in Docker is done by the Docker engine. And all that comes from a file in your project called the Docker file. Here is an example Docker file from my project. We're going to go step by step through and explain what this does, but first I'm going to show you guys what it actually looks like to go through a Docker build. So if I change branches here, it's amazing how everything you know about doing anything on the CLI vanishes the moment you're giving a talk. If I mess anything up, you guys can feel free to laugh. All right, so now if we take a look at what's in this folder, we have our Docker Compose and Docker file that we saw earlier. There it is. Okay, so now what I'm going to do is I'm going to clear that out, and I'm going to run a Docker build, and I'm going to name this the demo app. That's what -t means. It tags your image with a name, and I'm going to use the source code in my current folder to build that app. Okay, now a bunch of stuff happened really, really fast, which is totally cheating because I had already built the image before. I'm going to use this no cache flag so you guys can actually, oops, maybe not. That might not be a thing. Hold on, let me make sure I know my, no, that was right. I just put it after the dot. Yep, that's not allowed. All right, cool, no cache. There we go. Okay, so now you can see what's going on here. It's going through step by step in the file, and it's actually doing the things it's talking about. The step 0 here is it's going out to the Docker Hub, and it's pulling down an image that has Python 3.4 already installed for me, so I don't have to worry about that stuff. This is a special thing with Docker, since to view Docker's logs, a lot of stuff with Django's runner doesn't actually come out in the console if you don't put this environment variable in, so that helps out a little bit with that. Expose 8000 is a way of telling other things that may interact with this container that it's exposing a service on port 8000. The work directory is a way of saying, assume everything else I'm doing is happening in this directory from this point on. So it's just saying this is the spot where the action's going to happen. Okay, here's where things start to get interesting. Copy requirements.txt. That's actually going to take my requirements.txt file and copy it into the Docker image. So right now, the only thing in the image is Python and my requirements.txt. The reason for this is if you remember earlier, I talked about caching each one of these steps. You can actually see where it says a little hash under it. that hash represents the layered file system image for that particular step in the build process. Your container is basically all those images chained together and layered on top of each other. So what this actually does is it lets me make sure that this step doesn't have to be rerun. Docker's really smart. It can tell when this file changes, it knows it needs to go all the way back up and run step 4 and all future steps again. So what this does is if we didn't have this, then anytime any file changed in our container and we did a Docker build, it would have to reinstall all the pip requirements, which sometimes can take a while if you've got an app with a lot of dependencies. So what this does is we copy ingest requirements first, we pip install the requirements. You can see here it installed Django and the Postgres package. We come down here and then we say copy. We want to take all the rest of our source code and we want to copy it into our application directory. And then the last piece of information here is the command. That's saying when I run this image, the default command I want it to use is run app. Well, what's run app? Well, if I can type right, run app is a little bash script that very simply runs the Django migrations to get our database up to speed and then runs the Django development server. In reality, you would not want to run it that way because it's not very good to use the Django test server in production, but it gets the job done for this demo. So let's do a Docker build, or we just did a Docker build. Let's do a Docker run now. So we have our image built, and if we run Docker run and we type that same name as our image, let's set up a port here. We want the app to run on port 8002. So what this is doing is saying on my host, I want to map port 8002 to port 8000 inside the container. The way Docker works is unless you tell Docker to let things in and access that container, it doesn't let other things read that container. So when I'm saying Docker run, if I want to expose ports on my host so I can access them via localhost, I have to run that. So I'm going to run, I believe I named it demo. So I'm going to run Docker run, demo. It's going to run my migrations, and then my server is started. If I pop back up here to my browser, and I run localhost 8002, we get an instance of my guestbook up and running, which is pretty cool. So what makes this so neat is now I have this image that I've built of my app. All the libraries, everything it needs are contained within the Docker image. And what's the next step? Let's go back to the slides. That's always a good place to start. Probably not at the beginning though. There we go. All right, couple things here. There's multiple ways to start containers and stop them. Let me kill this container real quick. So one way you can start a container is on your servers. When you run a container, you usually want to run it with the -d option so that it runs it in, whoops, how did that happen? All right, run it with the -d option. It prints out a little hash, and now if we run docker ps, you can see that my demo application is running and forwarding port 8002 to port 8000. So we can go back and make sure, yes, the app is running. But how do I see the logs of what's going on in that app? That's why we have the docker logs command. The docker logs command, as you can see here in the usage, you give it a container name. Like in this case, this particular container is called, it gives them cool computer science-y names, like suspicious cray. And you can specify a name when you run the container with --name, but in this case we'll just use this one. And when I did docker logs, you'll see it spit out everything that has been outputted to the standard out or standard error of that container, which is pretty cool. All right, so now how do we stop it? How do we get rid of it? Well, if we look at docker ps, we can use either the hash or the name, and we can do docker stop along with that name. And now our container is stopped. All this has been running locally on, well, it will be stopped, hopefully. Sometimes it takes it a second to convince it. There we go. All right, and now it has stopped. Very cool stuff. All right, let's hop back up here to our slides. Move that over there. Okay, cool. So just a review of what we've seen so far. Docker build. Docker build takes your Docker file, which is a recipe for basically how to build the image for your app, and turns it into an actual image. Docker run takes your image and actually turns it into a container. Docker logs lets you view the logs from a running container. And Docker PS shows you what containers are running right now. All that stuff is pretty cool. All right, everybody still with me okay, pretty much? All right, good stuff. We'll move on to the Docker Hub and talk about that really quick. So the Docker Hub, I mentioned a second ago, hub.docker.com. It is a website here where you can search. Let's say you are working on a Django app like I was. There's actually an official Django image here that you can base your app off of and be able to pull that in by saying from Django, and then when you do a Docker build, it would actually pull this image in, and you wouldn't have to even run those pip install commands at all. Or in my case, I know you guys really want a copy of that guestbook app, so what I'm gonna do for you guys is I'm gonna go ahead and publish that online here. I'm going to create a repository. I'm gonna call that repository my guestbook app. Freaking awesome guestbook app. Create. Okay, now we have this Mark Adams / guestbook application. Now we are going to tag my demo app and we're going to name it Mark Adams / guestbook. And now we can say Docker push Mark Adams / guestbook. And now what it's going to do is it's going to take that image that I just built and those layered images, and it's going to push them up to the Docker Hub. And by the end of all this, you guys will actually be able to install Docker, run Docker pull Mark Adams / guestbook, and you will have this awesome guestbook that you can run on your own servers. Congratulations. Okay, cool. We will let that finish its thing. It'll be done by the time we get done here. Yeah, Docker push, Docker pull, if you want to just pull down an image, that's another thing. I'll show you guys that really quick. It is super straightforward. For instance, let's say I wanted to try something in Ubuntu, for instance. If you remember, most Linux distributions all have the exact same kernel, more or less. It's just those libraries and other programs, package managers that come along with the operating system that actually make all the distributions different. So if I say Docker run and an image name like Ubuntu, I have to give it this command line flag. I'll explain that in a second. And run bin bash, what you'll see here is I already had that Ubuntu image loaded, but now I'm running a shell inside of a Ubuntu Linux environment where I can run and install, if I want to install, you know, Python 3, for instance, I can, or maybe I should learn how to install packages first. There we go. I can install Python 3 inside of this environment. Actually, it's already installed. And whenever I exit that environment, it just dies. It's a lot cheaper than spinning up VMs, but has the same effect. If something's going to work if I want to test my app in Ubuntu or CentOS or something like that, or have my app run in those environments, using those containers is a much cheaper way to do it. So you can actually Docker push and Docker pull those images down as you need them. And one other thing, the Docker Hub source code is actually available on GitHub, so you can actually run your own private Docker registry, and there's all sorts of instructions online about that. If you have a company and you want to keep your images non-public, you can actually run them behind the firewall as well. All right, let's keep going here. Docker Compose is pretty cool. It describes all the components of an application using a YAML configuration file. Okay, what's that mean? Well, in our example, we're declaring two parts to our application. If you guys remember earlier, I mentioned maybe we want to run this with a Postgres database because we want to do stuff that SQLite doesn't support. What we can do here in this YAML config is we're saying we want to have our application have two Docker containers associated with it, a web container and a database container. The web container, we're going to tell it, you should run Docker build and use the source files in this directory. Super. We want you to expose the app on port 8000, and we want to set these environment variables. Okay, all that makes sense so far. We'll talk about this links thing here in a second. The other thing is this DB. We also want to create a container called DB, and we want it to use the Postgres 9.4 image. So when I run Docker Compose, it's actually going to build this web container, and then it's going to go out to the Docker Hub and download the Postgres already made image for me. And then the magic happens with this links thing right here. I could do all this stuff manually. Like if I wanted to do Docker run And let's say I wanted to create a Postgres container running on my system. I could say docker run Postgres 9.4. We'll say, hey, run this in the background, and we want to name it DB. Okay, boom. Now if we look at Docker PS, I have a Postgres 9.4 server running on my computer, spun up just like that. If I run docker logs DB, you can actually see all of the Postgres startup information being outputted to the logs. Pretty cool stuff. And now I want to run my app. If you guys remember earlier in my app, I set this database host variable. I'm going to do the same thing here, except it's going to be a lot messier looking. I'm going to say docker run demo, except I'm going to say -e. And I'm going to say database, or well, a couple things first. I'm going to say I want to link the DB container to my container, and inside I want it to be called DB. I'll talk about what that means here in just a second. And then I want to do database host equals DB, database name whoops, that's not going to work, equals Postgres, database user equals Postgres, and I decided I would get creative with the password and also make it Postgres. Okay, so now what's going to happen is when I run this, unless I made some sort of dummy syntax error like I would expect myself to make, it's going to start a version, it's going to take our image, our demo image here, and it's going to start an instance of it. And that image is going to have these environment variables set inside of it. And then it's going to create a link to an already running container, which is our Postgres container, so we can use that. And I'm also going to put a -d here. Hopefully, what did I miss?
-d before database.
Yep, there it is. Good job, guys. Paying attention. Glad you caught it. All right, boom. In theory, that should have worked. Let's see. Okay, cool. So it looks like we have our server running, and then we have our Django app running here, but I wasn't paying attention, and I didn't do the port like I mentioned earlier. So let's go back and try that again. Stop that container. And then we will go ahead and run this command again, except we will tell it, let's run this on port 8005, map to port 8000 inside the container. Okay, now we're up and running. We can see here my app is up and running, and if I do localhost 8005, here's my guest book, and it is running, and we know it is running against Postgres instead of what it was running before, because if I go ahead and I just arbitrarily kill that database server and I refresh, uh-oh, this doesn't look good. Yep, my app is definitely broken now. Yeah, there's no way that's going to work. Okay, you guys get the idea. It's super broken now. It might have even died. It didn't die. Let's kill it. Because I killed its underlying database container. Now you got to admit, that's kind of a scary command and not super helpful. Like, you have to know a lot of stuff to get that command to work. So let's talk about something different. Docker Compose. As we just mentioned, Docker Compose, you'll notice that all this stuff in here looks vaguely similar, if you've been paying attention at all, to those command line arguments. And that's because that's what they are. If we run Docker Compose up, what's actually going to happen here, well, it's not going to happen right now because my slides are running on the wrong port. We'll kill my slides for a second. Go back over here. All right, if I run Docker Compose up, whoa, all sorts of stuff happened, including my database or my app not working right. That's normal though. Let's try that again. There we go. All right. That was just a quirk. We don't worry about that. Nobody saw it. We'll cut it from the recording. So when I ran Docker Compose up, you see what it did up here was it spun up an instance of the database container, and then it spun up an instance of my web container. So if I go back and I do localhost 8000, here's my guestbook running again with the database. The difference now being that instead of having to deal with all those different command line commands and starting both containers manually, I was able to do it using a single command. So when this stops here in just a second, okay. So Docker Compose up starts it. If you need to rebuild your container, let's say you have some new source or something like that, you run Docker Compose build, and it will go through the Docker files that you have, and it will rebuild them so that you can actually have the app have updated code. One of the most important things, if you're going to use this in local development that's really useful, is you can actually, in your Compose, let's zoom this in a little bit. In that Docker Compose, you can use the volumes. Let's make sure I didn't just make that up. There is a volumes thing inside of the YAML file. Nothing embarrassing about using documentation during your talks, guys. Remember that. Volumes, there we go. Okay, cool. That is exactly what I thought. So if I do volumes and I say I want to take my current path and I want to mount it to user source app, what this is actually going to allow us to do is back here in our build, whoops, whichever, this guy, when we do Docker Compose up and everything starts up, what's actually going to happen now is instead of using the files that were in that container we built, it's going to use our local files, which means that on my computer, instead of using the files we copied into the container, I can actually go in. Let's say I went into my guest book and I went into my views.py and I made it count 2 hits instead of 1 all of a sudden. We'll just make an arbitrary change. Then you can go back here. And if I did it right, which it appears I did not, then it would actually detect and restart the source code inside the container, which is pretty cool. I'll leave that as an exercise for you guys. Let's go back here to this guy. All right, let's talk. So just a quick review. Docker Compose up lets you take a bunch of containers of different types. For instance, we could add a Redis server to this or anything else. You can wire them together and have all the configuration there in one easy file to just bring everything all together. Docker Compose build rebuilds all the Docker images that have Docker files in there, and Docker Compose stops the different containers. Okay, now the last big part of the component we want to talk about here is Docker Machine. Docker Machine actually allows you to provision and manage Docker hosts. I have an example of this that I recorded as a video because AWS takes forever and we would be here all day. With Docker Machine, you can see right now we don't have any Docker hosts running. If I run Docker Machine create, I can specify a driver, Amazon EC2 in this case. I can give it my credentials, which like I said earlier, I have craftily hidden in environment variables so that you guys don't mess with me later. Oops, typo. Good to have typos in your demo videos. Again. All right, what's going to happen here is when I run this command, it's going to use my credentials, reach out to Amazon EC2. It's going to provision a brand new Docker host for me, running the Docker, running boot to Docker, which is an ISO they make to run Docker in the cloud. And it's going to call it demo VM. So what's going to happen here is we're going to wait around for about 10 minutes and it's going to finish provisioning, or I'm going to skip it in my video. And you can see here when I ran Docker Machine LS, now I have a Docker machine set up called demo VM running on EC2 on this IP address. And I can SSH in by running Docker Machine SSH. That lets me connect straight to that Docker host so you guys know I didn't fake it. And then I can sudo, because this is a demo and that's what you have to do. Don't run things as root in real life. You guys know that. And I'm just going to run a Docker container here with BusyBox to echo that it worked so that we can see that it actually did make a host that can run Docker. So it downloaded the image and it printed out, it worked, it actually worked. So cool. All right, so Docker Machine, oh, one last thing. I think it actually shows this here too. When we get out of that machine, when you decide you don't want Amazon charging you money anymore, you can actually take that machine and run Docker Machine RM, and it will destroy that machine. And you didn't have to know anything about really AWS besides having your API keys, which is pretty cool. All right, so Docker Machine supports a number of providers, pretty much every major cloud provider out there, including Rackspace, which I was told I'm supposed to say Rackspace at least 5 times during this presentation since they're a sponsor. They are one of the ones on the list, Google's Compute Engine, Azure, EC2, all that stuff, and even VirtualBox locally. You can actually run Docker Machine to set up another Docker VM locally if you want by saying Docker Machine create driver equals VirtualBox. You can call it demo VM2. And now all of a sudden, I am provisioning a VM using VirtualBox, which you have to already have installed. It creates an SSH key for me automatically, injects it into the virtual machine, and within, you can see my network adapter showed up there in VirtualBox. It's going to boot up the VM, and then you'll have a functioning Docker host up and running pretty quick. Or one day. It might not be pretty quick. You guys generally get the idea. That will finish here. Let's hop back to this slide. So Docker Machine lets you create a new Docker host either locally or in the cloud, lets you SSH into it, destroy it, and then probably the coolest command is Docker Compose, or these all should say Docker Machine. That's a super big typo on my slides. I will fix that before I post those. Once this VM starts, the Docker client, if you guys remember, is pretty much very small and just sends commands to the Docker host. In this case, I'm running Docker locally on my machine, but I want to connect to my new VirtualBox VM. If I run docker machine env and the name of my machine, it's actually going to spit out a series of environment variables. These environment variables tell my Docker client how to connect to that machine. So a good example would be, let's say I just run my demo app here. Okay, so I have my demo app running on my machine right now. If I do Docker PS, you can see that container's running. If I take these environment variables and I run them, okay, now when I run Docker PS, you'll see I'm actually connecting to that remote Docker host and there's no containers running on there, which is pretty cool. So the Docker client can actually talk to any Docker host, whether it's local or remote, and execute commands just like you were running on that Docker host. And that applies to Docker build, Docker pull, Docker push, Docker run, all that stuff. All right, cool. So just to review what we've learned so far, you learned Docker build, how to actually build containers and go through that recipe. You learned how to use Docker Compose to take a bunch of different containers for all your different services, Postgres, Redis, whatever you wanted to, link those together with your web app. And then lastly, you learned how to actually provision a Docker host in the cloud. And finally, we'll talk about orchestration for the remaining 1 minute of my talk. This is a big area right now. As you can see, there's a lot of commands involved here, a lot of different things to do, but there's a lot of promise in the cloud with this idea of you just taking your app, putting it up on the cloud, and everything working. Well, these orchestration tools are part of trying to find that solution. What the orchestration tools do is you can take a file similar to that Docker Compose file that describes your app and the containers involved in your app. And you can provide that to these orchestration tools, and they will dynamically provision the hosts that those containers will run on, and will also provision those containers. So you can configure stuff for scalability where it'll scale up the number of containers or scale them down depending on load. And these tools will help you take care of that. Apache Mesos is one of them. It's a cluster manager. All these have some pretty cool cloud concepts involved, like high availability, scalability, being able to handle all that stuff. As you can see with that architecture we talked about with having the web container and having the database container, if our web load increased, we could spin up as many database containers as we needed to handle all those connections. And that's what these tools help you do, is manage that process. Mesos is one. Kubernetes is one that Google has helped develop, and it's pretty popular right now. And then the last one is one called Docker Swarm, which is one that the Docker ecosystem has created. And Docker Swarm is really neat because what it lets you do is it lets you run multiple Docker hosts that are linked together with a Swarm agent running on each one, connecting back to a Swarm master. Then you can connect to the Swarm master with your Docker client using the environment variables like we saw with Docker Machine. And then your local Docker client can launch Docker images onto that Docker Swarm cluster, but it treats it like it's a single host from your point of view. So it makes it really easy for you to ship to like a huge cluster instead of just a single machine to help you with your scalability stuff. There's a whole bunch of parameters, whole bunch of stuff surrounding that there's definitely not enough time in the -2 minutes left in this talk. But I do encourage you guys at 5 p.m. There is going to be a lightning talk about Docker Swarm by somebody who is pretty awesome from Rackspace. One, two, and I guess I'll say Rackspace one more time to meet my quota. But they'll be there talking about that. I encourage you guys to check it out. And that's it for me. Follow me on Twitter if you want. My stuff is all online on Bitbucket at markadams/PyTexas 2015. Thank you guys for coming.